Our final lesson for the first half of Chapter 5 is 5.4, Solving Radical Functions. In this lesson, we'll look at equations that have one radical or sometimes two radicals with different nth roots, and we'll solve and find the validity of those solutions. To solve radical equations, we have a couple of steps to follow. The first thing you want to do, and this is something we've done before, is isolate the radical term. If anything's being added or subtracted, we move it over. To then get the radical out of the equation, we raise each side to the nth power. So whatever the root is, we do the same, but in a power form. Once you've done that, we solve for our variable. Usually it's x, but whatever the variable is that's given. Checking for extraneous solutions is only required for an even root. So if the radical is even, check for extraneous solutions. And I'll show you what that means with examples. Okay, taking a look at the two examples on the right, I'm just going to make sure I don't kind of there we go. Now I have some room. The first example, the square root of x plus 5 minus 1 is equal to 3. We want to isolate the radical. That means we want to get this entire thing by itself first. To move negative 1 to the other side, the opposite operation is to add 1. And we have the square root of x plus 5. On the right, we have 4. Step 2, raise each side to the nth power. Well, the square root is technically the second root. I'm going to raise both sides then to the second power. Canceling out the radical and the power, and we're left with x plus 5. On the right, 4 squared is 16. Now solve. Subtract 5 from each side, and we get x equals 11. So it said if the radical was even, we check for what's called extraneous solutions. We have to plug this back in. And what we're looking for is to make sure we don't get a negative on the inside of that radical. If we plug x in, it's 11 plus 5 minus 1 equals 3. 11 plus 5 is 16. The square root of 16 would be positive 4. We don't do the plus or minus unless we're solving a quadratic. And 4 minus 1 equals 3. That checks. X equals 11 is a valid solution. Let's try the next one. Now we have 3 times the cubed root of x plus 2 equals 18. In this example, our radical is the cubed root of x. That means we want to isolate just that much of the entire left side. Thinking order of operations, we need to get rid of the 3 that's being multiplied and the 2 that's being added. But to move things over, we need to move the 2 over first by subtracting. That gives us 3 times the cubed root of x equals 18 minus 2, which is 16. Now divide by 3 to get rid of that coefficient out in front. And that gives us the cubed root of x is equal to 16 thirds. If the root is isolated, we then raise it to the nth power. In this case, meaning the third power. If we do the same thing on the right-hand side, x is on the left. On the right, we have to distribute the 3 in. You may want your calculator for this one. 16 cubed is 4,096. 3 cubed, that's on our list. That's 27. This is a cubed root, which is odd. That means we don't have to check our solution. It would not be extraneous. Let's try a little application with the Golden Gate Bridge. If any of you have ever been to the Golden Gate Bridge, you know that walking across that bridge is no easy task. It's very windy along that bridge, and there's a lot of traffic, so obviously you stay on the sidewalks. But they have those 2 tall towers kind of on the ends with the cables in between. It says the suspension cables from the Golden Gate Bridge's towers are further above the roadway near the towers, as you can see, and closer to the roadway towards the middle of the bridge. You can figure out your distance from the middle of the bridge in feet and the height of the suspension cables in feet at your position by using this equation. X equals the square root of y minus 220 over that really long decimal 0.010583. About how far is the cable from the roadway if you're 200 feet from the middle of the bridge? So X is where you are at in relation to the middle, and Y is actually the height of the cable at that location. If you are 200 feet from the middle and we're trying to figure out how high up the suspension cable is, we plug in X equals 200. And this really just becomes an equation to simplify for Y from there. If we set 200 equal to that big square root, well, actually it's not quite so big, is it? Y minus 220 over 0.010583. To solve this, we want to get y by itself, which means we have to isolate our radical. That means we have to multiply the decimal 0.010583 on both sides. 0.0501, whoops, here we go, 0.010583. If you multiply that on the right, they cancel out. And that gives us just the radical, y minus 220. On the left, if we multiply those two together, I got approximately 2.1166. To get y, or get rid of the radical, we have to raise it to the nth root, which means we'll square both sides. 2.1166 squared is approximately 4.479996. On the right, cancel out the power. We have to y minus 220. To move y over, we'll add 220. Or to get y by itself, we'll move 220 over. 220 plus 4 point all that decimal would be 224. We'll say 0.48. That's the approximate height of the suspension cable at that location. So if you're 200 feet away, you're looking kind of like maybe like something about that height right there. Like maybe this is you, and that would be the height of the suspension cable. Plugging that into the square root to verify it, if you plug in positive 224, you would get a positive radical answer. So that would not be extraneous. Here's another solve situation. Solve the radical equation. Square root 3x minus 2 is equal to x minus 4. Step 1 is to isolate the radical, and it looks like that's already done here. Step 2, raise each side to the nth root. Now watch what happens when we do that. If we square the left-hand side, that's business as usual. It'll cancel out the radical. But when we square that right-hand side, you have to remember to FOIL here. If you don't, your answer will not work out the way it's supposed to. Oopsie, that was an exclamation point. Well, that didn't work out the way it was supposed to. Close enough. All right. On that left-hand side, the radical and the power cancel, and we have 3x minus 2. On the right-hand side, if we write out x minus 4 twice and FOIL it, we're going to get x squared minus 4x minus another 4x plus 16. And that gives us x squared minus 8x plus 16 on that right-hand side. And on the left, we have 3x minus 2. Because this is quadratic, if we're trying to get x by itself, we've got to solve it like a quadratic function, which means we need to get everything on the same side. And that's something we haven't done for a while, but make sure that you remember those rules still apply. To solve it like a quadratic, we have to set it equal to 0. I'm going to subtract 3x and add 2 to get 0 on the left-hand side. On the right, we have x squared minus 11x plus 18. There's no a coefficient to have to do the earmuff method by. If we try to split the c to get the b, what are two numbers that multiply to get positive 18, but add to get negative 11? We could do negative 2 and negative 9, and then x and x. Negative 2 and negative 9 would add to get 11x in the middle and multiply to get 18 at the end for the coefficient, or the constant. And remember, these are both equal to 0. If we split them up separately, I almost put a plus there, caught myself, and then set the other one equal to 0 separately, x has two possible solutions. It could equal 2, or it could equal 9. Now let's check them to make sure they both work. Remember, with an odd root, you have to check for extraneous solutions. I'm going to start with x equals 2. That's an equals right there. If I substitute that back into my original equation, that's going to be 3 times 2 minus 2, and then I have to plug it in on the right as well. 2 minus 4. Simplifying, 3 minus 2 is 6 minus 2. The square root of 6 is 4, and the square root of 4 is positive 2. But on the right, 2 minus 4 gives us negative 2. If we're trying to solve, we can't have a positive output on one side equaling a negative output on the other. That means 2 is extraneous. Let's see if 9 works, otherwise both of our answers would be extraneous and we'd have no solution. I need to make my screen a little bit bigger so I have enough room to prove that 9 will either work or not work. So if I check x equals 9, we do the same thing. So I'm just going to give myself a little bit more space here. Plug it in on the left-hand side and the right-hand side. 3 times 9 minus 2. We want to make sure that either will or won't work for the right-hand side, 9 minus 4. 3 times 9 is 27. 27 minus 2 is 25. And the square root of 25 is 5. On the right, we have a match. 9 minus 4 is 5 as well. 9 works, therefore 9 is the only valid solution. And that'll be it for the video. We'll work on the second half of the notes for 5.4 in class tomorrow.